Hello and welcome. In this video, I'll explain how we tested our AEBS project. The goal isn't to go into the technical details of SCADE test, but rather to give you a basic overview so you can understand how we approach testing. Let's dive in. First, let's open the File Test window. Here, you can see how we structured our tests. We've organized them into two different records, one for the Adaptive Cruise Control, ACC, and one for the Advanced Emergency Braking System, AEBS. Inside each record, you'll find files that define aliases, set default values for variables, and contain the actual test logic. For example, in the AEBS record, the file ADAS underscores aliases is used to create aliases, which makes our tests easier to read. The init file defines default values for all the key variables, ensuring a consistent starting point. Now let's look at some specific tests we've written. Let's start with a requirement from the ACC system. The cruise speed shall be managed only when the cruise control is enabled, meaning on STDBOI or INT states. In SCADE test, we located this requirement in the file ACC speed near the beginning. Here's how the test works. SSM:cycle1-. This advances the internal clock by one cycle, ensuring all default values are initialized. SSM, set current speed 89.29. We set the vehicle's current speed to 89.29 kilometers per hour. SSM, set ACC true. The ACC is deactivated. SSM, set ACC is set true. We try to set the cruise speed while the ACC is off. SSM, check cruise speed 0.0. Finally, we check that the cruise speed remains unchanged, which should still be 0, as defined in the init file. This test ensures that the cruise speed cannot be managed unless the ACC is enabled, validating the requirement. Now let's move on to the AEBS record and examine the second test. If the time to brake is greater than the time to collision, and if both the accelerator pedal and the brake pedal are not pressed, the AEBS shall trigger the brakes. The output AEBS state shall be set to braking. In this test, we simulate a vehicle traveling at 100 kilometers per hour with an obstacle detected. Here's how it's set up. The vehicle's speed is set to 100 kilometers per hour. An obstacle is detected in the vehicle's path. Both the accelerator pedal and the brake pedal are set to inactive, simulating the driver not taking any action. The test then checks if the AEBS triggers the brakes by verifying that the output AEBS state is set to braking. This test confirms that the AEBS activates as expected under these conditions, ensuring the safety-critical feature functions correctly. Now that we've seen how to write and understand these tests, let's look at how to execute them. It's simple. Just right-click on the main folder and select Execute Tests. When you do this, a new window appears, showing the results of all your tests. As you can see on the screen, all of our tests have passed, which is great news for the reliability of our project. Before wrapping up, let's talk about test coverage. By running the coverage tool, we can identify which parts of the system have been tested. Green areas indicate fully tested elements. Orange areas are partially tested. For example, if a Boolean was only tested for true but not for false, red areas are not tested at all. While achieving 100% coverage is rare and often unnecessary, it's important to focus on the most critical parts of the system to ensure its safety and reliability. And that's it for this session. Thank you for watching, and I hope this video helped you understand how we tested our AEBS project. If you have any questions or want to learn more, feel free to check out our other content. See you next time.